On the screen is an assembly of a guitar effects pedal. Musicians often use this device to alter the sound of their guitar. Traditionally, the housing of the pedal is made of bent sheet metal, which can withstand the rigorous stomping by the musician. However, I'd like to explore an alternative design and make it out of ABS. If I'm lucky, I can even print it through an additive manufacturing process. Looking at my initial design, I'm concerned that the force of someone stepping on the switch might compromise the housing. Normally, I would have passed this design on to the analyst to analyze it. Now with Creo Simulation Live, I can continue to refine the housing and visualize the analysis results dynamically. With the housing part open in Creo Parametric, you'll notice a new Live Simulate tab. This is how you'll access the Creo Simulation Live functionality to apply loads and constraints and run the simulation. Selecting the tab will create a new structural analysis and apply a force to the top of the housing and constrain the bottom surface. Once defined, we can start the simulation. Immediately, you'll see the simulation results displayed on the model. In this case, the max deformation for the component is approximately 3.8 millimeters. Changing the display to von Mises stress, you can see that the max stress is approximately 43 megapascals. This shows the speed of Creo Simulation Live. No longer do I need to wait for the results to be processed, they are shown instantaneously. For my design, I'd like to try and minimize the deformation greater than 60%. This will help reduce the wear and tear on the pedal and potential future warranty issues. Selecting the Model tab, I'll start to make my design changes. Using one of our common user-defined features, I'll incorporate it into the design. Choosing the seed surface, datum plane, and location point, the UDF is automatically placed. Once I mirror it across the other side, you'll immediately see the results update on the screen dynamically. This is due to the fact that Creo Simulation Live Solver runs continuously throughout the session. Placing another fixed constraint to the UDF we just placed, you'll see the results update automatically. This is due to the fact that Creo Simulation Live Solver runs continuously in the background. Based on these design changes, I can see that the deformation has reduced slightly to 3.7 millimeters and the von Mises stress reduced to 38 megapascals. Not bad, but my goal was to reduce the overall deformation by 60%. Selecting the location point and modifying its position, the results once again update dynamically. Now we have significantly reduced the overall deformation and achieved our goal. Changing the display to the von Mises stress, the stress did go up slightly, but even with the stress values, we are well below the tensile yield stress for ABS, so we should be okay. As you can see, Creo Simulation Live allows users to explore different concepts and ideas using analysis-led design methodologies. Through a common user interface and simplified workflow, any engineer can set up and run a simulation on their models. Running continuously in the background, any change made to the model updates the analysis real time, providing users with immediate feedback if they are moving in the right direction.